Hello everyone, good evening. I hope you all are doing well. Today I came up with a very new video which is based on the recent red team activity which we conducted in one of the during one of the engagement in which we identified the AGP connector port was open, and the very first thing when anybody gets the AGP connector port 8009, the first thing that come up in the mind, let's run the Ghostcat, which we also did, but we were failed drastically. The magic bytes and everything was drastically failed. None of the exploits were working. We thought the servers are patched. We thought that everything is working fine, but we were able to read the web XML files. So we knew that the vulnerability exists, but and the engagement was, because we were not able to find anything. So the engagement was to to compromise something. From there we can land into the domain controller or some other places, and all those things. So it's a very interesting one because default exploits were not working. So we developed the whole new framework for the Ghostcat vulnerability, which we named as the Ghostcat pawn, which is very interesting. When you will run it in your lab environment, you will find enjoying learning this particular exploit. So for example, like what exactly happened was, so we were running a recent internal red team engagement where we stumbled on a legacy Apache Tomcat, which was, I think the version was 8.0.53, if I'm not wrong. And what we did, we ran a quick port scan, which was like not the running by nmap scan, because nmaps, you already know that if you're running a red team engagement, nmap will be detected for sure. So we ran a very simple Python script in which we sent a packet for each one port with a time bound situation, and then we identified that the port 8009 was open. Okay, and what happened whenever the 8009 port usually open, we know that it's an AGP port, and the very first thing that comes into mind is exploiting the Ghostcat vulnerability, which is CVE-2020, I think 1938, which is nothing but a very famous file read and the remote code execution vulnerability. So as like the normal exploiter, I downloaded the GitHub POCs or the scripts which are present online, and I tried to exploit it, but nothing happened. Okay, so either the script crashed, or I was getting the weird magic byte errors which were x41, x42, and or the HTML pages were returning with 5xx, basically the HTTP error code for 5xx. But interestingly, what was happening at the back end, because I was able to read the web XML file using a slightly modified version of one script which I identified on the GitHub. I modified the script a little bit, and when I ran it, I was able to read the contents of the web XML file. Okay, and I actually got the database password from there, which was very interesting, very interesting. And this told me that the vulnerability was there, but the tools which were present online were not reliable. Okay, so what I did, because we had to go ahead and exploit it, even the customer where we were running it, they even gave the go ahead, okay, try to exploit it. So instead of giving up, we decided to understand the protocol ourselves and write a bulletproof exploit, and not just a file reader but a full pen testing framework, which I am calling it as the Ghostcat pawn. Okay, so this is the same thing which I have written. This is my GitHub repo link. You can download the complete exploit framework, which is written in the Python, because Python is something that I really like to write my codes in. So this is the full Python framework. I will go to each and everything in coming pages. So understanding Ghostcat, what is Ghostcat? Ghostcat is nothing but a vulnerability that is affecting the Apache Tomcat's AGP, which is nothing but Apache JServe protocol connector. Okay, now what is Apache JServe protocol? It is a binary protocol that lets a front-end web server talk to a back-end Tomcat container. and it runs on port 8009 by default. An AGP message starts with the magic bytes, normally 0x12 and 0x34, followed by the length and the data packet. The data packet has the code bytes, which are, I think I have written it somewhere. Yes, I have written it here, which if I'll say the data packet has the code bytes, which is the 0x02, which is the forward request, 0x03, which is send body chunk, 0x04, which are the headers, and 0x05, which is the end response. Now, there is something which we call it as the attributes as well, which I will explain. I think I have written it somewhere. Yes. So these are the attributes, which are called as the forward request, which includes these attributes. Now, two special type of attributes which are used internally by Tomcat for request dispatching, which is the servlet include request URI and the servlet path. Now, what happens is if you send a fake forward request directly to the AGP port and set these attributes, Tomcat will include the file you specify as if these were the part of the application. Okay. Now, if you request a file with a text file extension, what happens is Tomcat will serve the raw content that's nothing but the arbitrary file read. Now, if you trick it into the treating the file as the JSP by using the JSP in the URI, in the request URI basically, Tomcat will compile and execute the file that will result in the remote code execution. Looks scary, but it is very, very interesting. So the same thing I have mentioned over here. If I'm going to set the servlet part to any file inside the web application, which is the web.inf or web.xml, Tomcat will treat it as a static file and return the content. Now, if I have to run the eval, which is nothing but the remote code execution, I have to set this servlet part to a file that contains the JSP code. Now, if the request URI ends with the JSP, Tomcat will compile and execute the file as a JSP. And this is the workflow, which I have written as here itself. Now, with the time, you can go through the workflow. But I will tell you why my exploits failed, because that is very, very interesting part. I think I have written it somewhere here, I think in the above. Just a second. Yeah, the initial challenge basically. So why most of the public exploits failed? Because they are hard coded the expected response magic bytes to 0x12 and 0x34. But what happened in our target, the server was replying with 0x41, 0x41 basically the hex codes for A and B, 0x41 and 0x42, which are nothing but the ASCII. If you convert this into hex into ASCII, it will become AB, which is completely breaking the script. Now, what happened was, now other scripts which assume the host header, that had to be sent to a special AGP code, but the Tomcat instance, the instance that was running at the server end, the Tomcat instance basically rejected that and wanted the plain string headers. Okay, this behavior we identify it is as like a very, very not a normal behavior. And also passing commands via query string didn't work because these included the resources don't inherit the original query string. Now, these little quirks made the public tools useless for our specific target. But what we knew as the protocol, we could build our own packet builder that adapts to any magic bytes, sends header as a plain strings, and passes commands via the request attributes. Okay, and that is what we have built as the Ghostcat pond.py. So if you go to my basically script, this is the Docker file which you can use it to deploy the vulnerable server. Now, when building the exploit, so what we did, we armed this basically this thing, and we inherit the packet equal to bx02, which is and plus the method byte and the protocol and the request URI. Okay, and then we added the remote address and remote host and the header bytes and the attribute bytes, and we ended with the B and XFF. Now these attributes are the key, so we defined the attributes. The first hurdle was the non-magic bytes, so we added, because when we were sending usually the magic bytes, that it should add it as the, we were getting the 0x41 and 0x42, which we wanted to get rid of. So we went ahead and then for code execution we wrote this. Okay, now when we were building the whole exploit, so we added a lot of stuff which was missing, and we took the reverse. Not only we were able to run the remote code execution, but we also took the reverse shell as well, and that is included in our script as well. Now I will basically I will demonstrate as well. So if I'll go, what you need to do, you have the Docker file as well automatically with you. You just need to build the Docker file with the docker build -t command, and you need to run those. Let me just showcase it to you how you can build it. So I'm not gonna build because it's gonna waste our time. I have already built the lab. So just run the docker build -t Ghostcat lab and run the Ghostcat app inside the Ghostcat lab. Okay, and the container will running. Okay, so if you want to see docker ps, my container is already running as the Ghostcat. Okay, so I have already written the commands here. If you want, you can I've already created a readme file over here for you guys, which you can look into it. Okay, step by step basically. For this you just need an optional PySox. I found out that in Ubuntu PySox was required, but in Kali PySox was already there, so I added it over here. Now these are the commands which we will run it. So if the very first command that I have to check whether this particular instance is running with the Ghostcat. So Python 3 Ghostcat pond dot sorry, let me just Control C, clear the screen and run it. Now it is running on my basically localhost, so I will give the localhost IP. If you have the remote IP, you will get the remote IP. Now if you see the the Tomcat is running with the vulnerability, and we were able to read the web INF file. Okay, sorry, web XML file, and the contents as well. We were able to read the contents. Now if I have to scan the AGP port, whether the AGP port is running or not, so I have added, so rather than using the nmap, you can run my script directly, and you will come to know whether the AGP port is working or not. Okay, some errors, scan port is not defined. Sorry, just a second. 3 Ghostcat. So I've added the scan, this is fine. Maybe I need to modify the script. I will update the script and I will add it. No problem. The port is there. Let me just copy it once again. Okay, some issue with the code here. Argument. Okay, no problem. I'll check this particular point and we'll update the script if the script has issues. But what I wanted to show you is the remote code execution. So if I'll exit it, basically, so Python 3 ghostcat pawn.py RCE 127.0.0.1 009. If you want to see what's the command, you can see it over here, but it's very simple. I have kept everything very simple. So you can run it via exec and you can also run it via RCE. I can show you here. Here you go, and you can run basically the command like this. Okay, and you can run localhost and then uploading a JSP shell. Who am I? I am the root. You can also run ID. You can also run ls. Okay, so this is how we can we can run the remote code execution on this particular instance. Now the biggest thing which I wanted to showcase is that our framework which we have created will also have the reverse shell. So how we can do, you can again take the help option, or you can just run Python 3 ghostcat pawn.py. Then you will get rev shell localhost 8009, and I have already created a reverse shell. Like if you want to see rev.jsp, so very simple JSP shell which I created, which is nothing but running the which is having my Kali IP and which is running on port 443, and it will run the command bin/bash. So let me just open the port. Let me run the command again, and here we go. We got the shell over here. So who am I? I am the root, and from here so it was actually running on the Windows server. I demonstrated on a Kali Linux, but it was actually running on Windows server. So what happened was we executed all the commands using the Windows, and we actually got the shell, and from there we started getting we dumped the hashes as well. We ran the impacket silent modules. We dumped the LSS, and from there we got the hashes, and we actually relayed those hashes, and then we did the rest of the activity. Now I have also added one particular module, which is the snatch, which will loot each and everything for you. So Python 3, I think, just a second, if I'm not wrong, Python 3 ghostcat pawn.py snatch, and I will just run the localhost. I will localhost. Okay, extract secrets not defined. Okay, so let me just run it again. Just bring this to there. Scan, read. Let me just download the script one. I don't know, I think I made some changes to it. Let me just go raw. Let me just copy it. I don't know what's, I think I made some changes in this. That is why it is behaving abnormally. So if I'll I don't know what's the issue. Let me just fix it. Just give me a second, I'm rebuilding the code. So where is extract underscore secrets? Where is the definition for this? Secrets. Okay, let me just fix it in my Sublime. Let me just define extract underscore secrets, and then I think everything will be done. Give me 2 minutes. Yep, so it is working. So I have defined the snatch keyword snatch function as well, and it is working well. I'll update the script here as well. Let me just update it on my GitHub. So I defined the function. Let me just update it. Actually, I was testing a lot of other stuff as well, so I think I might have played around with this. Let me just Ghostcat testing. Let me just copy this link for you guys. And let me update it. Let me paste it. Sorry, commit changes, and it should be done. So yeah, so once you will see the loot file, you can go to the loot localhost 8009, and you can see all the files which are present. So currently I only have the webinf web XML file. So let's see if we are able to find the secret. Yes, so it is there. I have also defined the scan as well, so let me just try the scan, otherwise I will define. Yes. uh, Oops, sorry. So run it. Yes. So I have defined the scan function as well, so it is working very well. So this is my basically Ghostcat framework, which I developed recently, and it is actually free from all the magic bytes, which you can run it in your testing environment, lab environment. I have already given the Docker file, so let me showcase. You just need to build the Docker file and everything will be built for you. Okay, and I have also given the command JSP file as well. If you see, so this is the remote code execution file. If you want to push this file directly to the web server, so for example, if you're not able to run the commands, you can upload the shell directly, if put allows in the web dev directory. So that's all for this video. I hope you have enjoyed this video, and just a small disclaimer I want to put it in the end, that this particular basically article was only for educational purposes and authorized for security testing only. I don't encourage the black hats things as of now. So make sure that when you are trying, your environment should be a controlled environment. And if you find this useful, please give me a clap on Medium. You can follow me on GitHub, subscribe me on YouTube, connect with me on LinkedIn and on Twitter. Usually Twitter I have stopped using, but you can connect me on LinkedIn. So thank you everyone. I hope you have enjoyed the video. Sorry for some script messed up, because I was just testing certain things. Uh, I was doing certain stuff at the back end. I think that's why I messed it up. But overall, the code is working fine. You can test it in your environment. Thank you everyone. I hope you have a lovely weekend ahead.